As it reaches the upper layers of soil, it becomes progressively heavier and thicker. But sometimes its migration is blocked by a layer of impervious rock. This is when it accumulates drop after drop, creating immense natural reservoirs. Trapped miles under our feet, subjected to intense pressures, one only needs to drill in the right spot to make it spring to the surface. Millions of years of fossil energy condensed in this slimy black liquid are at the disposal of anyone who wants to use it.
Welcome to the memory of humanity. Every historical event, regardless of how small, is recorded and connected. You only need to change one to upset all the others. Here, we are able to control time, analyze and compare billions of events in order to rewrite history in infinite ways. For example, imagine our world without hydrocarbon. The most visible consequence would be in transportation. Our cars, as well as trucks and boats, run almost exclusively on oil. Without it, we would have stayed with the energy giant of the 19th century, coal. But coal is an energy source much less powerful than petroleum. To obtain the same yield, we would need to cover the planet in coal-fired power stations and drill until the ground resembled Swiss cheese and the forests were in danger of disappearing. With a coal-fired boiler, it would be impossible to get an aeroplane off the ground, let alone a rocket. Deprived of satellites, we would not have cell phones or GPS devices. We would travel on trains, steamers, or zeppelins. Without petroleum, plastic would not exist. Plastic has revolutionized our way of life, medical and sanitary hygiene, food packaging, and electronics. Petroleum has been one of the most powerful players in humankind's development.
Titusville, 1859. In this pioneer Pennsylvanian city, Edwin L. Drake drills and extracts petroleum for the first time on American soil. Soon, the little town is covered in oil derricks, and the population explodes, going from 250 to 10,000 inhabitants in just 5 years. The discovery launches a veritable black gold rush. Up to this point, the industrial extraction of underground deposits has been deemed impossible. Drake's idea is simple. Suspend a drill, a massive piece of steel, from a cable, and use a steam engine to propel it. August 27, 1859, he succeeds in piercing a layer of impervious rock which contains crude oil. Gushing to the surface, the precious liquid marks the beginning of a new age, the era of the industrial exploitation of oil. Very quickly, deposits are discovered all over the world. Oil companies flourish, fighting in a frantic race to get the best deals. Production goes from 6,000 barrels in 1858 to 150 million in 1900. From then on, oil is not only used for lighting, but also for heating and powering car engines. Petroleum quickly becomes a pillar of the economy. Countries are unable to continue developing without their own secure and abundant supply of hydrocarbons. In the aftermath of World War II, under the combined pressure of price increases and rising demand for energy, deposits, which were previously considered economically unsustainable, are exploited. We dig deeper and deeper, under even more extreme conditions. We understand that natural oil resources are much more extensive than the drilling techniques are allowing us to exploit. In the 70s, The petroleum industry launches an assault on the oil reserves in the North Sea, which were previously untouched. To defy the elements and obtain the deposits buried several miles deep, sturdy oil rigs are constructed. This is the beginning of offshore drilling.
Giants of the seas. An oil rig is a structure designed to extract, produce, or store hydrocarbons on the high seas. There are 17,000 in existence around the world. Among them, certain are permanent and can extract deposits located 1,000 feet deep. Others, floating and motorized, specialize in drilling in much deeper waters. This is the case for the Deepwater Horizon station. This type of rig, equipped with giant floating devices and diesel engines, readjusts its position continuously to keep the drill perfectly vertical. Its derrick makes it possible to lower the drill string, a long line of hollow rods screwed end to end, several miles under the ocean floor. At the other end, a hard steel drill digs through the Earth's crust, searching for a pocket of petroleum. As it digs, mud is constantly added to keep the drill cool, evacuate debris, balance the pressure, and stabilize the well. During the drilling operation, the well is reinforced using steel tubes and cement to minimize the risk of accidents. The rig workers live with a great fear, a kick or sudden and violent eruption of highly pressurized oil or gas. To reduce risks, a complex mechanism called a blowout preventer, or BOP, allows one to instantly block any reflux in the tube. In theory, if all these security systems are operational, an accident cannot happen.
April 2010, the Gulf of Mexico, 45 miles off the American coast. The ultra-modern Deepwater Horizon platform, leased by the English company BP, just finished one of the deepest drilling missions in history. On the platform are 126 highly specialized personnel. Their mission: drill the wells, stabilize them, and then leave room for the exploitation platforms. Deepwater is a technological gem. Thanks to it, BP is able to reach deposits that were previously inaccessible. Still, on April 20th, the multinational company is behind schedule. Each day, it is losing around $1 million. It is high time to reach the last step of the drill, the creation of the temporary cement plug before another production unit takes the relay. 11:15 a.m. The team in charge of checking the cement leaves the station without carrying all of the tests required by law. For some time now, BP has risked security by squeezing budgets and cutting corners. The tests are considered too long, too expensive, and superfluous. 7:55 p.m. On the drilling bridge, the operations team performs a pressure check. The goal is to verify that the cement plug sufficiently blocks the petroleum from rising. The test comes back negative. This is a bad sign. This can indicate a significant problem, involve serious setbacks, and prevent the platform from moving. So, they decide to use another method of measurement. The new results are interpreted as positive. But 3.5 miles below, thanks to a flaw in the cement plug, oil and gas begins seeping into the well. 8:52 p.m. The pressure falls in the column. The well becomes unstable. From the dark sea floor, the hydrocarbons rise uncontrollably to the surface. 9:40 p.m. A worker notices mud on the drill bridge. Quickly, he engages the first security measures. On the seabed, the annular of the blowout preventer is blocked in order to prevent infiltration. It's too late. The hydrocarbons are already rising at full speed inside the column. On the drilling bridge, a mixture of mud and oil burst in the air. The well is erupting. They try in vain to activate the blowout preventer, but because of the pressure, the tube has changed shape. The ultimate safety tools are not responding. Tearing through the darkness, the alarms sound. Gas, highly flammable, floods the platform. The situation has become explosive. The horrible smell of gas is everywhere. One small spark is all it takes.
Fighting an oil spill. Petroleum does not dissolve in water. Because it's lighter than water, a large part floats on the surface in compact pools. The immediate danger is to the marine life. Mammals who need to come to the surface to breathe, or birds who find themselves trapped by an oily ocean. Because oil blocks sun rays from penetrating the surface of the ocean, it prevents the photosynthesis of plankton and slowly asphyxiates the ocean. If nothing is done, the final stage of an oil spill is a dead ocean in which no organism is capable of living. To fight against these pools of oil, one can create floating dams which help protect the coastlines. One can also burn the pools on the surface or use dispersants which split up the pools into droplets. This will accelerate the natural deterioration process. If the oil manages to reach the coastline, the remaining methods to fight against permanent damage are very basic. Shovels and bulldozers will be used to clean the damaged beaches. In all cases, stopping the origin of an oil spill is always the main priority. Without that, the fight is lost before it has begun.
11 people die in the initial explosion. 115 are trapped on a sinking platform with flames raging everywhere. Blistered by oppressive heat, choked by hydrocarbon vapors, the men mechanically execute the gestures they repeated dozens of times during training. The level of chaos is indescribable. The fire, fueled by an entire field of oil, burns out of control. Rescued by a supply boat, the men of deep water can only contemplate, helplessly, the extent of the disaster. All know that the damage has only begun. In the middle of the night, the Coast Guards who received the distress call from the station used the full power of their boat to head in the direction of the spill. In the middle of the morning, firefighters approached the furnace to put out the flames. It's a fruitless effort. April 22nd, at 10:21 a.m., the Deepwater Horizon platform, critically damaged, sinks with 2,600,000 gallons of oil on its surface. The steel tube that connected the platform to the well twists in agony under the weight of the giant, then breaks and vomits an endless stream of crude oil into the heart of the ocean. Millions of liters of oil each day. May 2nd, to reach the leak and seal it, BP launches rescue well drilling expeditions. But it will take months. The race against the clock has begun. The fate of the Gulf of Mexico is on the line. Everything in the arsenal is deployed. Floating containment dams, controlled burnout, attempts to reactivate the blowout preventer using underwater robots. But nothing works. A state of emergency is declared. As of May 15th, all attempts by BP to stop the spill have failed. The Coast Guards authorized the use of CoreExit 9500, a powerful oil dispersant sacrificing the marine ecosystem for the sake of the coastline. Debates rage over who has legal responsibility for the hundreds of miles of coastline already affected. June 1st, The bleeding lasts for over a month. In July, the efforts are just beginning to pay off. A new containment decreases the flow of the leak. Beginning of August, the BP engineers managed to inject mud directly into the drill string and slowly stem the flow of oil. The well is officially stabilized, but it still isn't definitively sealed. September 16th, the emergency drilling finally reaches its goal and injects tons of cement into the well. On the 19th, the nightmare ends. It lasted 5 months. All that remains is for the bill to be paid.
We have arrived at a point of divergence. A point of divergence is a key moment, a crossroads in our history where our world can swing from one side to the other. The sinking of the Deepwater station resulted in one of the worst oil spills in history. After 5 months of fighting, the BP company finally succeeded in plugging the leak. Previously, in 1979, another oil rig had also exploded and sank. The leak, which was less severe, was stopped after 9 long months. If BP had not managed to control the leak, the environmental consequences, which are already extensive, would have been immeasurable. The Gulf of Mexico waters, deprived of sun, saturated in oil, and devoid of oxygen, would have become dead zones where life would no longer be possible. To protect what was left of it, immense permanent dams would have surrounded the US coasts for hundreds of miles, trying to give bathers a sense of normalcy. But beyond the dams, the disaster area would be a dead sea abandoned to its fate. A petroleum ocean.
Close to 200 million gallons of crude petroleum have been released in the waters of the Gulf of Mexico. The devastating impact on wildlife and vegetation is impossible to quantify. The spill spread over nearly 24,000 square miles, killing hundreds of thousands of marine animals and damaging 1,000 miles of coastline. The most terrible ocean-based oil disaster in history. Yet, compared to the global impact of the oil industry on our world, it is unfortunately only a drop of water. In 2016, the worldwide production reached nearly 92 million barrels a day. Extracting and transporting all this oil poses delicate geopolitical problems and fuels greed. Only a few countries, creating a kind of monopoly, possess the bulk of the world's reserves. In 1970, the price per barrel was at $1.80. In 2008, it reached $146, 80 times higher. Each barrel that is produced is a source of tension. From the energy crisis of the 1970s to the 1990 Gulf War, any oil crisis seems to be, in essence, a political problem. A motivation for development, black gold is often the impetus of war. The economic and strategic stakes are huge, as is the direct involvement of oil in the emission of greenhouse gases, recognized today as the main cause of global warming. Stuck between dwindling reserves, wars, financial stakes, and climate challenges, humankind seems compelled to find new energy solutions. But that is another story.
Each liter of petroleum is an ultra-concentrated fossil fuel that has accumulated since the dawn of time. A phenomenal power trapped in tiny pockets dispersed throughout the planet. By harnessing it, humankind has managed to thrive as never before. We are completely addicted to this fuel source and use it without restriction, even to the point of disturbing the balance of the global climate. Thanks to oil, we have known abundance, but everything comes at a price. We are currently living beyond our means and squandering our resources. This fossil fuel exists in limited quantities. Petroleum is not a renewable energy. The more we consume, the less there is. While demand is only growing, supply will eventually drop and tensions will rise. Post-oil era debate raises many concerns. Some think that we should immediately stop burning all hydrocarbons. Others refuse to sacrifice their lifestyles and rely on science to find new sources of energy. The solution, as it often is probably a little of both options. One thing is certain. A period of important changes is imminent. Changes at least as monumental as the ones that followed the discovery of oil.